problem set. You guys were assigned A through G on the problem set, and all you had to do was, what did you have to do? What's that called? Okay, find the common denominator and then make the, now I'm really stretching your minds because it's been a while since we've talked about this. Okay, you make the chart, and what's the chart list? The chart has a whole list of fractions, but what do we call those fractions? Everything down the same column is called this. Perfect. So first you find the least common denominator and you make them equivalent fractions. So on A we had 1/2 How would I start that with the chart? How would I start that with the chart? Let's see. I'm going to draw some sticks today. How would I start that? Number 2, what do you think?
You put 1/2 in one side and then 1/3 on the other, and then make a line of numbers.
Oh, okay, thank you. Yeah, you're right. It is, isn't it? Okay, so 1/2 on one side. They did 1/3. Remember, we made this line and we said, what is this? Times 1. Now, did some of them have to go past 5? Yeah, some of them had to go past 5. And in that case, you just keep going. But I usually just go up to 5. I know Miss Manford showed you a way the other day. That's the way I used to teach the kids how to do it. But we need to start with this method first because I'm not quite sure what you're going to see on the state assessments. You may see something just like this, and you need to know how to do it, right? So now what do I do?
On the 1/2, you would do 2 times 1 and 2 times 2.
Perfect. 2 times 2, or 2 times 1 is 2. 2 times 2 is 4. Then what do I do? Connor?
And then you can go over to 1/3 and times that by 2.
Okay, so 2 times 1 is? 2 times 3 is? The rule is whatever you do to the bottom number, which is the denominator, you do to the top. That's the numerator. And if I multiply the bottom number times 2, I have to multiply the top number times 2. So now I have times 3. How's that work?
3 times 1 is 2.
Okay, 3 times 1 is 3. 3 times 2 is 6. Then what?
Then you take the 2 times 3, which is 6.
Okay, the 2 times 3 is 6. Now what do I do?
No, on the 1/3.
On the 1/3?
Oh, what? Take the 1 times 3, and that equals 3.
Okay, 1 times 3 is 3.
And then 3 times 3 equals 9.
3 times 3 equals 9. Do I have any common denominators yet? Once you see a common denominator, do you have to just keep going and going and going? No. Raise your hand if you can tell me what my common denominator is. When I have the numbers 2 and 3, what's my denominator going to be? 6. So if I go to my denominator under 1/2, what's my numerator going to be? 3. If I find my denominator of 6 under 1/3, what's my numerator going to be? Oops, 2. This is what your paper should look like, right? You should have written on your paper 3/6 minus 2/6. When you're doing equivalent fractions, don't reduce until you're done, until you have the answer. I've had kids in the past come to me and say, "Where's Evelyn? I reduced them and now I'm back to that." The whole reason we find the equivalent is so that you can subtract it and you have the same denominator. So you could reduce these. If I reduce 3/6, what would I reduce it to? Yeah, it would reduce all the way to 1/2, wouldn't it? And 2/6 would reduce all the way to 1/3. Now, we've talked enough about fractions that we know that when we have a common denominator, what does that mean? When we have a subtraction problem with the same denominator, what can we do now? Okay, you keep the bottom number. So my denominator is 6. And then what do I do?
You can subtract the top number.
Okay, how do I subtract it? 3 minus 2 is 1. Well, that's pretty easy stuff, isn't it?
This is a lot easier than it.
Yeah, it is, isn't it?
A lot.
It doesn't require much thinking, does it? If you know how to multiply a number by 2, 3, 4, 5, then you're pretty much good to go, aren't you? That's what I heard. They were talking about math on the radio today. And I told Mr. Burns on the way in, I said, I'm kind of torn in between the two because sometimes I don't understand why I have to teach you a certain way, but then I start looking at it. I never knew really what a fraction looked like. My teachers always just said, do it this way. And I just did it that way, but you kind of can see now where we're going, can't you? You have a visual representation with all the pictures we've drawn and the number lines. So when you have a common denominator, it stays the same, and you subtract the numerators. Where things start changing, though, is when we have whole numbers. So let's look at a whole number problem before we move to lesson 12, and I show you how to borrow, and then I'll let you guys finish your assignment. It won't be too difficult to finish it now that you have all of this stuff already done, right? Okay, we have whole numbers. Let's do let's do G. 5 6/7 minus 2. Now here's what I don't like. Anytime I have multiplication, addition, subtraction, I don't write my numbers like that. Do you guys write your numbers like that? That makes it kind of difficult, doesn't it? So you need to learn that immediately when you see them side by side and you want to write them on your paper, when you're working with the numbers, I would do it just like this. 5 6/7 minus. Does that make it a little easier when they're on top of each other? Okay, I'm going to draw a stick to see what someone got for that problem on G. I just want your equivalent fractions that you found with the common denominator. And I've already looked at them. Everybody did it, so you shouldn't be sweating bullets right now. Number 20. Yeah, what number did you go? What number did you have that went with the 6/7? I'm sorry? 1821. Raise your hand if you have something different than 1821. I would say she's right then. So what I do is I go over here and just cross that out. Because when you have multiple numbers, it gets confusing, doesn't it? So number 14.
For the 2/3, I got 5/30.
5/30. Did you get 18/21s for the first one? No? Okay, work through it again real fast. Let's see what you get. What'd you get?
Well, I have a quick question.
Okay.
When you do, like, it's a number and your answer can be simplified, do you see if both numbers can go, or like can be divided up into two? Is that how you do it?
What was our last answer that we just had? For A.
1/6.
I'm sorry?
1/6.
1/6. So let's say we had the 2/6. And remember, you would do the upside down cake. Put 2 and 6 inside of here. And what goes into both 2 and 6? 2. How many times does 2 go into 2? How many times does 2 go into 6? So 2/6 reduced is the same as 1/3.
Okay, so because on E, I got 4/30, and then that being like a really big number, so I divided them both, and then I got 2/16.
Okay. That's E's the one we're working on right now, right?
No.
We're working on G. Okay, so when you subtracted, what'd you get?
On E or G?
E.
I got 4/30, when I subtracted.
Okay, so 4/30. Put them in the box. What goes into both those? Remember, always start low. When you choose big numbers, some of you are not familiar enough with your multiplication facts to sit there and choose gigantic numbers. You'll be sitting there like half the day trying to figure out the biggest number that goes into it. So, start 2, 3, 4, 5. 2. G goes into 4 how many times? 2. How many times does 2 go into 30? 15. Is there anything that goes into both 2 and 15 besides 1? How do we know 2 doesn't go into 15?
Because the 15 is an odd number.
There you go. 15 is an odd number. So is it possible to have a big old candy bar that has 15 sections and only 2 left? Yep. Would it be possible to have a candy bar with 30 sections and only 1 left? Yeah, so it's okay if your fraction's large. The reduced form of it, though, is 2/15.
So do you have to do the birthday cake, or can you just split it up into 2?
You can divide it out. You can do remember what I said earlier about whatever you do to the top, you do to the bottom? You can divide it out and say, divide the top by 2, divide the bottom by 2, and just keep going.
Okay, so if you got like the answer 10/30, it could be 5/15. You could just do that in your head, or do you have to work it out?
10/30
10/30.
would be 1/3.
Oh yeah, you have to think.
So here's the deal.
Yeah.
Here's the deal. You always want to work it out. Trust me. Because there have been times, even remember in our math book, when I was having to do my own answer key, that I'm like, okay, I did that one wrong, and you guys tell me the right answer. Okay, number 14. You got your common denominator now?
Yes.
Okay, what is 2/3?
15/21.
15/21. Anyone get anything different? What'd you get? 14/21. You know, I think we have so much differentiation on this thing that we're gonna let's start a chart. Keep a chart on your desk, bud. Let's see what happened. So we have 6/7, 2/3. And we take it times 2. 6 times 2 is 7 times 2? 2 times 2? 2 times 3? Any matches yet? Nope. Times 3. 3 times 6 is 18. 3 times 7. And we already know we're going to keep going, right? So basically, this problem would be the 7 times 3. You take the two denominators times each other. 21. So how do we get this? What do we have to multiply by to get to 21, Connor? 7 times 3. So we multiplied 3 times 7. So what do you think I'm going to multiply the top number by? 7. So what would my answer be then, up on top? 14 over 21. Now remember, you want to go over here and cancel that out, because when you have like all those fractions next to each other, it is confusing. What's my next step? Turn to your neighbor and talk to your neighbor. What am I going to do? Talk about the answer? Once you have the answer, look back up at me. Everybody's quiet, like boom, all of a sudden. Okay, number. Dun, dun, dun. Oh, well, you guys got lucky. I just called number 7. 22. 22. What is your answer?
3 and 4, 21.
3 and 4 over 21. Anyone get anything different? What'd you get?
4, 3.
Okay, but did you remember the whole number? Don't forget to subtract the whole number, too. So if you subtracted the whole number, then what would you get? 3, because 5 minus 2 is 3. Well, when you do a subtraction problem, you always start at the... Which side do you start on? When you start a subtraction problem, which side do you start on? When you start an addition problem, which side do you start on? Which side do you start on? You start on the right. Remember, to the right, to the right. You do that with fractions, too. Why would I want to start on the right? Why do you think I want to start on the right? Okay, so you don't get confused. Why else? If you need to borrow, the bigger numbers are always to the left. You know, when we're talking about the number system, remember, every place you go in whole numbers, how much larger is that place to the left than the one to the right? How many steps does it go up each time? Remember when you're talking about the number system and you start with the... Yeah, it goes up 10 every time. So 8, well, I have my common denominator. What do I do with it? Number 18. What do I do with it? What do I do with my denominator?
You do, well, okay, you have to find the, common denominator.
Okay, we got that. So then what's the next step we do?
Put the common denominator on the bottom.
Okay, because we know that both those fractions will go into 21. Now what do I do?
Whatever you took, to get 21, you do the same on the top, so.
Okay, perfect. So I did 3 times 7 to get to 21, so I multiply 6 times 3, right?
Mm-hmm.
And this one's multiplied 3 times what to get to 21?
3 times
7, and I multiplied the top times 7. So now we know we have equivalent fractions. So then what do I do? Miss 18?
Then you do the next one. So you don't need to do the denominator for this one because it's already like that.
Yeah, because we made it that way, didn't we? So now what do we do? Do you remember? What happens to our top numbers?
You multiply it by what you multiplied at the bottom.
Okay, well we did that. So we got that set. What are we doing in this problem? Adding, subtracting, multiplying, or dividing?
You subtract.
Subtract. So what do you think I'm going to do with my numerators that I have now?
Subtract
And what would I get if I subtract them? 18 minus 14, what is that?
That equals 4.
Okay, so I have 4 over
4 over 21.
21. Did I have to borrow to get that answer? I didn't, did I? So now, Miss number 13 with her hand up back there, what do I get when I subtract my whole numbers? 3. So the answer to G is 3 and 421. And I heard a lot of you say that when you got it, so good job. I'm going to take this one step further today. That's why last week I tried to have you find the common denominator for them. Okay, and then today I'm going to show you one more step, and I think you're to the point where you might get it. If I have this number, I want you to turn and talk to your neighbor about the process you have to use to subtract that number. Because I know right now, by looking at this, I can't take 8 from 5. If I have 5 fingers, I can't take 8. I want you to talk about the process that you use when you subtract a number that is larger than the number you're subtracting from. Okay, so talk to your neighbors for a minute. Come up with an answer. Okay, so when I have to subtract, go ahead. What did I have to do?
You have to cross out the 1 and add 10 to the 5 because you can't. If I have 5 and I have to give you 8, I don't have that.
Okay, so when I borrow from the column, remember, everything to the left is 10 higher, right? So when I borrow, I'm borrowing how many?
10.
I'm borrowing 10. So is that the way I would write it? When I borrowed 10? What do you think, number 6? You were shaking your head no. What do you think? What do I have to do? Is that the way you would write that? You drop a 1 next to 5. Well, how can you get that 1 next to 5? What do you have to do? If you put the 1 next to 5, it'd say 15. What do you have to do to the 10 and the 5 to make it say 15? Yeah, you're on the right track. You almost said it, and then you started second-guessing yourself. How do you get, what did I do with my 10 and my 5 to make it say 15? Yeah, you have to add them together, don't you? So if I had fractions and I had to borrow, what do you think I would have to do when I borrowed from the whole number? What would I have to do to the fraction then? What would happen to my fraction? I'm going to give you 30 seconds. Talk to your neighbor, and what do you guys think is going to happen when I borrow a whole number? What's going to happen to my fraction? This group, what did you discuss? What do you think is going to happen to your fraction?
Our fraction, we're taking a whole from our whole number, and then you have to make it a whole fraction. So say your denominator was 15, so then your fraction would be 15/15, be a whole fraction.
Okay, so
15/15 is 1 whole. It's not.
So you say if I had something like fourths, let's make my life a little easier here. I like 15ths, but you know, my lines are already a little crooked when I try fourths. So let's see this. So if I have fourths and I have that. What would that say as a fraction or as a mixed number? How would I read that as a mixed number?
4 and 1/4.
Okay, 4 and 1/4, maybe. What do you think? Why would you say 1 1/4? Okay, so this whole thing is filled, right? And when it's completely filled, that equals 1 whole, doesn't it? And this says 1/4. But if I wanted to break it up into a fraction, what kind of fraction would I have? What would I have?
You would have,
What makes up that 1 whole?
it would be 4.
How many total boxes do I have? 4. How many are shaded in? 4. So 1 whole would equal, 1 whole equals what?
4/4.
Yep, 4/4. Now, if I wanted to take this and add it all together, we know that, what are we dealing with? What's our denominator in this case? 4. If I took every box I had and I added them together, how many total? So if I were to combine these two, how many total fourths would I have? 27, what do you think? How many total fourths do I have when I combine them? No, what do you think?
5/4.
5/4. You guys need to make sure eyeballs are up here at all times because you are going to get messed up. So when I borrow 1 whole and add it to 1/4, it becomes 5/4. Look at your problem set, lesson 12. Problem set. And look at E. It says 4 2/7 minus 3 1/3. Okay, your job right now, I'm set my timer for 5 minutes. You can work with your neighbor. I want you to find a common denominator along with equivalent fraction and put them right here next to these two. You're lucky because we've already done 3/7 as our denominator. I'm going to set my timer for 5 minutes. I want you guys to figure out what this part equals. Okay, does anyone want to give me an equivalent fraction for the 2/7?
For the 2/7, 6/21.
6/21. Is that what everybody got? That's what I got. Good job. So you have 6/21. Cross that out. And who has something for 1/3? 7/21. Now bring down your denominator. It's 21, right? 6 minus 7. Can we do it? What do we have to do? Borrow. What are we going to borrow from? Go ahead. We're going to borrow 1 whole from the 4. If I borrow 1 whole, what's my denominator in this problem? What's my denominator? 21. So if I borrow 1 whole, how many am I borrowing?
21.
Yeah, so if I borrow 1 whole, I'm actually borrowing 21. 21/21, right? So what would that look like then when I'm finished? Because you would add 6 plus 21 equals 27 over 21. Now can I subtract that? Now can I subtract that? Jessica, what's the answer? 27 minus 7 is? Okay, look at both those numbers. 2 goes into 20, but it doesn't go to 21, does it? Nothing goes into both of these except 1 because they're so close together. So when you have to borrow, you pretty much just add. This is what I've always told everybody in the past. Now that you know what it looks like. What did we say it was? 621? This is what I've always told people in the past. Now that you know what that looks like to borrow, when you borrow, you just add your denominator to your numerator. So you have 21 plus 6 is, what would that become? 27. Okay, so don't forget when you're borrowing, whatever you're borrowing, you're adding the same denominator to it when you borrow one whole. Any questions before I give you this as an assignment? Yes, ma'am.
If it's an improper fraction, are you supposed to reduce it to this much?
Yep. If it was too big, I don't think you're going to run into that on this though, since you're borrowing and subtracting. If we were adding, that'd be a different story, and we'll be talking about that in the near future. I think that actually we skipped that lesson, and we're going to go back to it. So your assignment for tonight then is to finish your lesson 11. You guys already have everything written down. All you have to do is just subtract them. That's all you have to do, okay? And problem set numbers A through H.